Welcome to this lecture for Research Methods. We'll be talking today about quasi-experimental designs. Okay, quasi-experimental research. What is it? Well, typically, it's whenever you are interested in cause and effect, but you don't have all the features of a true experiment. That's why it's quasi-experimental, almost experimental. Typically, in quasi-experimental research, you are manipulating an independent variable. You are doing something to people, right? But what's typically lacking, what's typically missing that makes it quasi-experimental is lack of random assignment. Occasionally you will still see designs referred to as quasi-experimental where you manipulate an IV, you do have random assignment, but maybe you lack experimental control. You're unable to rule out other influences because you're doing something in maybe a field setting, not in a lab, and so it doesn't quite meet the full hallmarks of a true experiment. But most often it's that you don't have random assignment. So this is a lot of overlap with what we'll talk about with quasi-experimental research and something else called causal comparative research, which is really just a form of correlational research, right? If you measure, if you get a group of people and you measure two variables and you see, is there a relationship between those two variables? Well, that's a correlational study, right? But sometimes people measure these variables and they're measuring dichotomous variables. Let's say if you're a university student or not a university student, right? So they want to know, oh, is there some sort of effect of attending a university on maybe awareness of political issues, right? So they measure how much you know about some political issue, and they ask you, are you a university student? Have you ever been a university student? Yes or no? Right? And then they're going to try to draw causal conclusions between those two. Now that's not an experiment, clearly, and it's not even really quasi-experimental research because you're just measuring things. And it's maybe a little confusing because I think your book does refer to this as a type of, I can't remember what they call it, participant variable design, and they refer to it as quasi-experimental. It's not. It's just correlational. If you're just measuring things, you're not doing anything to anybody, it's not quasi-experimental. So that's correlational, sometimes referred to as causal comparative, when you're doing a collection study and trying to draw causal conclusions. So quasi-experimental research, though, again, it's not quite experimental. Well, if it's not quite experimental, that means I can't be as confident about the internal validity, about cause-effect conclusions. Then why do it? Is it still valuable? Is it still useful? Well, yeah, for a lot of reasons. One, it's often helpful in exploratory research. You're interested in maybe a cause and effect relationship. And maybe you've even done some correlational research where you've just measured variables. Okay, yeah, out here we measured the variables and we found this correlation. Now we're not confident enough to do the expense of an experiment yet, but we can go a step further and do a quasi-experimental design, still kind of exploring whether or not there is a relationship. It's also often helpful in bridging this kind of, there's this gap often between clinicians and researchers, right? Where clinicians will say, okay, when I'm reading this research, I'm like, okay, you found this, cool, but this study that you did of this therapy you did in some sort of lab setting on a university campus, the findings are useless to me because I'll never do exactly what you did the way you did it because you were so controlled and you selected this small group of people who were, you had all these inclusion exclusion criteria and all these things you did for good science makes it not relevant to me, right? And so the lack of kind of real worldness of ecological validity of some experimental research is off-putting to clinicians, so they don't use it. And then same thing, researchers, when they're studying things, if they're not paying attention to those ecological factors, they're doing kind of their ivory tower, doing their lab research, generating information, but maybe not useful information. Often quasi-experimental research can be a bridge between those two worlds, where, okay, it's a little messier than experimental, which, you know, the scientists are like, well, I don't like it as much, but okay, we'll sacrifice a little. And the clinician's like, well, it's still not exactly how I would do it, but at least maybe it's closer. It's a closer approximation to reality, has greater ecological validity. And so oftentimes these studies can serve as that bridge between the two worlds. And then third, often quasi-experimental research is done because the research isn't the primary goal, right? Where there's some intervention. Okay, we're going to be doing this. We're going to be doing this group therapy. We're going to be doing this public outreach campaign, whatever, because we have this goal to help people. Oh, and you want to study what we do? Okay, that's cool. But we're doing it, and no, we're not going to do it the way you want with random assignment, experimental control, these things, because that's not our main purpose. Our purpose is to serve these people. But you want to study how well it's working? Cool. That's probably going to be quasi-experimental, because again, the impetus behind the activity isn't research. Okay. The different types of quasi-experimental designs. Simplest type obviously would be a single group design, where you have no control comparison group and you're expecting people at one point in time, right? Where you have people that experience something unique or special, and then you measure some dependent variable and say, okay, well, these people are this way. Maybe it's because of what happened to them. So let's say you study a bunch of people who are psychopaths, and you measure to see how many of them were abused as children. Because you want to say, okay, well, look on this. 90% of these people who are identified as psychopathic were abused as children. Clearly, abuse plays a causal role in psychopathy. Well, obviously, there's some problems with that, because you don't know if you use this type of design. Well, compared to what? People that aren't psychopaths, how often are they abused, right? And also, do you know if they were psychopaths before they were abused, or do you know that they weren't, right? Can you rule out the directional arrow in this relationship? So it's got some problems. People still use it quite a bit. So to improve upon that, typically the next step in a kind of this kind of hierarchy of internal validity would be to then use a comparison group design. So you're comparing at one point in time this group to this other group, but you're not randomly assigning people to groups. They're typically existing groups. This is also sometimes referred to as a non-equivalent control group design. So you have a control group. Okay, there's two groups, and we're going to do something to one group and not the other. Or one group experiences something, the other group doesn't experience that thing. Problem obviously with this, again, you don't have random assignment. You don't know if the group that's experienced that one thing that you're doing that one thing to is somehow different than the other group. So you say, well, maybe we'll kind of try to step up a different way. Instead of just doing a comparison group, we'll go back to the single group, but do it before and after, right? So now we can look at this one group, we're going to measure them, and then do something to them, and then measure them again. Problem with that, the reason that's not fully experimental really, is because you don't know if that change over time is due to what you did, or due to maturation, history, testing effects, all things we've talked about before, right? So then you step up even further and say, okay, well, what about we combine these things and we do a comparison group before and after design? So you have two groups, and measure them both before and measure them both after. Also referred to as a non-equivalent control group, pre-test, post-test design. So of the ones we've talked about so far, this one will have the most internal validity, but it's still not quite to the experimental level because you're lacking that random assignment. There may have been initial group differences that you're not aware of, that you can't even see. So you measure them at pre, and they look like they're the same, but they weren't really the same. We'll talk more about that in just a minute. And then the last type is single participant designs, also called single end designs, and we'll talk about those in more detail after talking about some of the common threats to internal validity among quasi-experimental designs. Okay, threats to validity, and primarily talking here about threats to internal validity. Selection threat, right? So if you have more than one group, so you have a comparison group design or comparison before and after, now you've got these two groups. What you're worried about if you don't use random assignment is maybe you have non-equivalence, right? Because the main reason to use random assignment to group is to hopefully establish equivalence among groups, where we hope that, okay, on average, these two groups will be similar in intelligence, depression, and anxiety, whatever variables might be important related to the dependent variable. So you don't know that in a quasi-experimental design because you haven't used random assignment, but you can do a couple things to help deal with that. You can either, for both of these, you have to measure. So one, you can just measure and see, okay, are they equivalent? So you can measure some key variables. Okay, hopefully they were similar on intelligence. So measure intelligence, and afterwards you say, okay, yep, they were equal. Whew, thank goodness. If they weren't, okay, now I've got a problem, and maybe I can try to deal with that statistically, which can be tricky, but generally just keep your fingers crossed that they were equivalent. Or if you want to kind of increase your statistical power, you can measure and then match them, right? So you measure people in both groups on intelligence, and then you use kind of a match group design where you get the two most intelligent people, one in the kind of quasi-experimental group, one in the control group, and you compare them to each other, and the next two compare them to each other, the next two compare them to each other, these pairwise comparisons, right? So you use repeated measures ANOVA or independent samples, paired samples t-test. Right? If you had a match groups design, that could help establish equivalence some. But again, at least we can think they look like they're equivalent at pretest. Which again, we'll talk in a minute. Well, maybe they're not though. So you can try to deal with selection threats. Ultimately, you can only go so far. There are also several threats related to anytime you have any kind of before and after factor, right? A pre-post aspect to the design, either for a single group or a comparison group. We've talked about these before. We'll just kind of go over them briefly again here. Sensitization, where measuring them, asking them how depressed are you now, that could affect how I'm going to answer when you ask how depressed am I later, right? There could be practice effects if it's some skill-based measure of the dependent variable. You know, how quickly can you solve this puzzle? Okay, well, I'll probably be better at post than pre, regardless of what you do to me in the middle, because I've done this thing before. Or if you're measuring multiple times, I may get worse the more you measure. There's fatigue effects. Having pre-post may introduce demand characteristics, where you ask me how depressed I am, then you showed me a movie, and you asked me how depressed I am again. Okay, well, if you're asking me how depressed I am again, you must expect me to be a different amount of depressed. Otherwise, why would you ask me again? And so now that may be the fact that you're using the same measure twice may be a hint or a clue to me of what the study's about. I'm going to guess the hypothesis, and I'll then act in accordance with what I think you want to see, trying to help you out. And so in that case, pre-post would introduce a demand characteristic. There's also the possibility, particularly if you're looking over longer periods of time, of mortality or attrition effects taking place. And this is when people, after pre, before you get to post, they drop out of the study. Now, if they drop out of the study, you can't analyze their data, right? Because you're not comparing group 1 to group 2, you're comparing people to themselves in any kind of pre-post design. If you have no post for them, okay, they're gone. And so now you may find, okay, hey, look, this treatment worked. It worked great. You know, of the 100 people that started, 4 finished, but all 4 reported fantastic results. We were 100% successful. 100% successful with 4 people, right? So those people may have randomly had good things happen in their lives, and that's why they're doing better now. And so you're going to conclude the thing worked when it didn't work. Type 1 error. Right? So that's a threat to internal validity if there's too many people dropping out. And this can also be a problem. Another way that this can be a problem, so that's more of like kind of single group design. Even if you have a comparison group, you think, well, we can deal with that because, if there's 20 people drop out of both groups, okay, of those that remain, okay, we're still looking at, is one group different than the other? So when you have a comparison group pre-post, the real threat here is differential attrition. If you have more people, bigger percentage of people dropping out of one group than the other, okay, now you're not comparing apples to apples anymore. You're comparing apples to, okay, these were apples, now they're oranges because so many people dropped out. Again, anytime you have pre-post, there's also the possibility of history effects, and that's just where something is happening between pre and post that has an effect on the dependent variable other than what you did. And oftentimes people refer to this, it's something that happens societally. It can be. It can also be something that happens environmentally, in the room. Just anything that happens to the people other than what you want to happen, that's outside the bounds of the experiment, that affects the DV. That's a history effect. Maturation effects, again, people changing over time because they're going to change regardless of what you do to them. So with history effects and maturation effects, if you have a comparison group pre-post, obviously you can deal with that a little bit. It's not that those things won't have an effect. It's just that if maturation is a factor, both groups should be affected by maturation equally. Right? So, okay, both groups got better. Okay, well, when that happens, you can't conclude they both got better. They both changed. What you're looking for is, okay, did one group change more than the other? If one group changed more than the other, okay, some of the change for both groups may be maturation, but that difference can't be explained by maturation, because why would one group mature, have maturation effects, and the other group wouldn't? Maturation should affect both groups equally. Same with history effects, assuming they have the same environment. Okay, so jumping back for a second to what we talked about before, where the selection threat, where you try to measure or use matching to determine equivalence because you didn't use random assignment. So when you do this, you say, hey, look, yeah, we had equivalent people. Maybe. They may not have been equivalent. They may have looked equivalent. But really, because anytime you measure any variable, there's going to be some error. Right? Either their true score will be above or below the score that you are measuring. So whenever you're doing a pre-post study comparison group, selecting two groups, this is really more of a problem when you're selecting people that are have extreme values on your dependent variable, right? So you're doing a study on anxiety. You say, okay, only people with really, really high scores on anxiety can be in the study. So that means that even some people that aren't that anxious, but on that day when you measure them, their measured score was higher than their true score, they're going to be in your study, right? And you're not going to have many people whose true score was lower, that their measured score was lower than the true score in your study, because you're only selecting really high scores, right? So you have a bunch of people whose true score is lower than their measured score, but here's your measured score, you're in my study. I measure you, I do something to you, I measure you again. Now, if I hadn't done anything, I measure you again, and again, I misestimated your score. Your true score, how anxious you really were, not as anxious as I thought, because there's error variance in there. But I measure you again, am I going to be the same amount wrong, the same direction? Probably not. What typically happens is you regress to the mean. You come back to the average or your typical score. So, I'm an average 7 out of 10 of anxiety. On that day, you got me out of 10, right? No matter what you do, if you measure me again in the future, I'll be back closer to a 7. Doesn't mean I'll be 7. I may be down at a 5 next time, because the 5 and 10 they average together, right? It's going to average out to a 7. So they're going to regress to the mean. So if I measure you again, now the group is going to look less anxious, even if what I did didn't have any effect. So here you have basically masked non-equivalence, and this can happen where you have two groups and they look equivalent, but really they're not equivalent because you've got one group that's higher than they should be, one group maybe is lower than they should be. So when you have quasi-experimental research, you want to be careful not to select on people that have extreme scores. You want to get a good amount of variability in your groups. Okay, so one type of designs, I said we talk a little bit more about are single participant designs or single-in designs. So a single-in design, first of all, not necessarily single-in, right? Not necessarily n equals 1. They just typically involve small numbers of participants. And when we say single-in, it's because the level of analysis is at the participant level. You don't look at, okay, what's the average for this group? Let's say if I have 4 people in my single participant design, I don't say, okay, what's the average for those 4? I say, okay, for this one, what happened, for this one, what happened, for this one, what happened, and for this one, what happened. I'm analyzing each individual person at that individual single participant level. So obviously there's a long history of this type of design in psychological research, going back to Ebbinghaus, using himself as a participant in his memory studies, Skinner looking at children and also animals, pigeons and rats and all those things, where we've learned a really lot of important things about how people work based on single participant designs. Because one of the big knocks, obviously, against single participant designs as well, it's not generalizable. You found it here, but is it true of everybody? Well, what Ebbinghaus found in terms of the learning curve and the forgetting curve, studying just himself, that's incredibly generalizable. It generalizes across individuals, across types of information, with some exceptions. But yeah, so sometimes you can discover these kind of big generalizable principles with this type of design. Not always, but it's possible. So what does it look like? Well, in terms of the features, repeated measures. So it's not just pre-post. It's going to be pre, middle, post. It's going to be post 2, post 2, post 2, post 3, post 3, post 3. Right? So you're going to think in terms of phases with any kind of single participant design before you do something to them, because again, it's quasi-experimental, so you're going to manipulate something. You're going to do something to these people. Before you do, you want to get a baseline measure, so you get the baseline phase. So you're going to measure the behavior of interest, the thing that you're hoping to change with the intervention, and you're going to measure it at least 3 times, because you need at least 3 points to establish a phase. Right? If only you got 2 points, okay, it was low and low. Well, the next one could be high. Okay, well now it's not a trend. right? Or it could be low, high. Okay, what's going up? Well, not necessarily. If it's low, high, low, okay, now we know it's this sine wave, maybe, right? So we're going to measure it enough until we've got a stable baseline, and you don't know how much you need to measure until you start measuring. Depends on the behavior, depends on the situation. But you're going to measure enough until you see this kind of pattern where it's stable. It doesn't mean that you have this kind of all these dots that are a flat line where it's not changing. It could be that it's getting worse. Okay, yeah, every day this kid is getting in trouble a little more. They're talking more and more in class, but it's a steady increase, or it could be a steady decrease. As long as it's stable, we've got a baseline. We know what's happening. Right? If it's not stable, if it's up and down and up and down and then down again and down again and up again, well, if it's all over the place, well, how are we going to know that our intervention had an effect on it? Well, we're not. We have to have some level of stability. So we get a baseline phase, and then we have an intervention, and then during the intervention, you also don't just measure once. You're going to measure multiple times until you get kind of a stable pattern. Okay, they were trending down. Now are they trending up, or are they stable, or did they go up and then came back down right away? If it's back down right away, okay, then maybe that up was just a little blip and there was no effect. Right? So you've got to measure enough to see a trend, see a phase. Again, at least 3 points. So again, you want to see stability in those levels of those trends. Participants serve as their own controls. So again, it's at the individual level. You're comparing each person to him or herself. So their pre to their post. You're not comparing people across individuals typically. There is a big emphasis on replication within one study, where and you can do this a couple of ways, because you want to show that you have control over the behavior. You're establishing internal validity by all these multiple measurements and changing stuff, right? So you have baseline, nothing's happening. You do the intervention, okay, see it change, and then now maybe I take the intervention away. So the thing that was, I'm making you not depressed by doing this, okay, stop doing this, you should go back to being depressed, right? So I give you something and I take it away. That's a reversal design or an ABA design. That's one way to do it. Or I can do it where I show that I measure, I do something, you get better. Okay, now I'm going to look at a different behavior. So maybe that was depression. Now I'm going to look at, okay, I'm going to measure anxiety, and then I'll measure, do something. Look, see if I see the change in anxiety. Yep, okay, I've replicated this effect. This treatment works. When I targeted depression with this treatment, depression got better. When I targeted anxiety, it got better. So it's all about doing replication within a single study within a single person, obviously. As you can see. Oftentimes the analysis of the data doesn't require statistics or SPSS, just visual analysis of the data where the patterns are clear enough that, yep, you were at baseline, you were down here. When we had the treatment, you're up here. And then we did the reversal, and you came back to where you were when we stopped doing the thing that was helping you. So different types of single participant designs, reversal, ABA or ABAB, where again, baseline, intervention, back to baseline, and then obviously don't typically stop it. Okay, now we made you better, and now we took away and made you worse again. Have a good day. You always give the treatment back. That's always the last step to see if they get better. Again, phase change, and this can be where you vary the treatment. So maybe you do baseline and then treatment B, and maybe you don't see a change, right? So, okay, you're depressed. Okay, we start doing journaling. Oh, you're still the same amount of depressed. Okay, so now we're going to do journaling, but I'm going to have you also draw pictures, right? So that's treatment B1. I've altered the treatment B to be different. Okay, now you're being less depressed. Once I see that change, okay, now I might be able to go back to reversal, take it away, and see if the depression returns. Right? So it's one of the nice things about single participant designs. They're incredibly flexible, and you can change what you're doing based on the pattern you're seeing. You know, if the participant, the subject, is not getting better, do something different, right? Or if they're getting worse, stop what you're doing, do something different. You can do component analysis if you have kind of more complex treatment, trying to figure out which part of the multi-component treatment is being effective. So, you know, start with baseline A, obviously, and you come in with, okay, here's these two components. You're going to do these deep breathing exercises as well as progressive muscle relaxation, B and C. Okay, now we're going to take the PMR out and just do the breathing, and just B. Okay, now we're going to put it back. Okay, now we take B away. Okay, now we put it back, and we see what happens. Is it just C that's causing you to get better, or is it just B, or do they both have to be there for you to get better? Right? So you can kind of tease apart which part of an intervention is the most effective. Multiple baseline designs, and this can be across behaviors, one I alluded to earlier, where you're measuring maybe anxiety and depression. I start measuring both of those now. I get a baseline, and then I start targeting one of them, but not the other. Right? So I target depression, it should get better, and I want to see anxiety not get better. Right? Not yet, because I haven't targeted it. If anxiety gets better when I target depression, okay, either my intervention is bleeding over, or it wasn't my intervention that caused the change. Their life got better, right? But if I can show that only the behaviors that I'm targeting are changing while others are staying flat, okay, that's showing that, yep, this intervention is having the effect on the behavior. And obviously you start targeting different behaviors over time. You can do multiple baseline designs across participants. Again, this is where you have, let's say 2 or 3 people. You start measuring them all at once. And then you get baselines on, like, let's say all 3 people, if you have a group of 3. After 3 days, you've got a stable baseline. You start the intervention for one of them, but not the other 2. They're kind of like a wait list. Right? So intervention on that one for 3 days, and then you probably start the intervention for the second one, wait another 3 days, start the intervention for the third one, and the whole time you're measuring everybody. So you should be seeing the change happens to people only when you start the intervention. If it starts before the intervention, okay, then it was an intervention. It was something that happened out in the world, some sort of history effect. And of course, you can also do it. However, there are, of course, some obvious limitations of single participant designs. The biggest one being, again, generalizability. And not that the results are entirely not generalizable, just they have questionable generalizability. We don't know how far these things extend, right? When Ebbinghaus found for himself, okay, yep, I can remember this information, this much information, but after this many minutes, this many hours, this many days, I start forgetting, and I forget this percentage, this amount. Here's this predictable curve for me. Okay, we didn't know if that was generalizable or not yet. But they said, okay, well, I found it for me. I wonder if it's true for others. And then you go to the next type of study where you study it more broadly with a true experiment, perhaps. So you find the generalizability via replication and extension, but in and of themselves, limited generalizability. Sometimes when you're looking at kind of reversal designs, they may not work because there may be limited reversibility of the effects of the independent variable. Right? Obviously, if I'm treating you for depression, you're depressed, and then I have some intervention, a lot of those interventions, once I start doing it, okay, you're less depressed. Once I stop doing the intervention, for most effective counseling interventions, you don't go right back to being depressed, right? Because it's not like insulin, right? It's not something that's helping you right now. It's changing the way you think, feel, see the world. And me stopping talking about it doesn't make those effects stop happening. So reversal designs may not be that effective for a lot of things. They tend to be more effective for behavioral stuff. A lot of this research is used with kids with cognitive disabilities and impairments, that are doing kind of self-injurious behavior like head banging, where using kind of token economies and reinforcers and different things where we can say, okay, when we're doing this, when we have things going this way, yep, gets better. If we stop doing it, it goes back to being worse, right? Because they tend to be more responsive to these environmental stimuli. There are obviously some ethical concerns about reversal designs. Hey, you made them better, now you're making them worse. Yeah, but we don't know we're making them worse. We're saying, might we make them worse? And obviously you're monitoring, so you don't let them get anybody get hurt. Right? If you're dealing with depression, you're not going to let them, get to the point of suicidality or killing themselves. But there are some things you got to think through with that type of design. And the other thing, obviously, when we talk about these kind of testing effects with pre-post, with this you're measuring 20 times. So there are definitely some potential effects of measurement, of multiple measurements, in this type of design, as we would see with other types of designs as well. But again, it's one of those things where, for like if it was something where you'd see a practice effect, you're going to establish that baseline. You're going to have them keep doing it until, okay, yep, they're not getting any better from being measured, so I've exhausted the practice effect. Okay, now I do the intervention and see if I can make them even more better. So you can deal with multiple measurements within this type of design to some degree. Okay, as I said, one of the big reasons you do quasi-experimental research is to kind of bridge that gap between researchers and clinicians. And so a lot of the research is clinical outcome research, looking at, okay, is this intervention, this therapy, this counseling effective or efficacious? And so when we look at these outcome studies, they often talk about efficacy research and effective research being two different types of research, where efficacy research is, can a treatment work, right? And that's often when you're doing stuff where you're focusing really on internal validity. I want to be confident that, okay, if I see a change, I want to be confident that it's due to this therapy intervention, due to having people do this journaling, or monitor their thoughts in this way, or write this letter to this person having a problem with whatever it is. I don't want it to be any questions that it's because of this and not something else, right? So can it work? And then effectiveness, okay, once you know it can work, does it work in the real world, right? Typically you don't start with, okay, does it work in the real world? Okay, well, does it really happen? No, you start with, can it happen? And then once you know it can happen, okay, now, when people try to do this in a less lab-like controlled conditions, we go with that kind of quasi-experimental research. That's where that effective research often comes in. And so there's a difference in focus on internal validity for efficacy research and the greater focus on external validity and ecological validity for effectiveness research. Another thing to kind of keep in mind in terms of clinical outcome research when reading studies in particular is what do they do for their control group or their comparison group? Did they use random assignment or not? If they didn't, okay, how similar these two groups, how might they be different? Those are very important questions to ask. And then let's say they randomly assign people to groups. One of the big things we saw a lot for a while, I think it's changing now in therapy research, is you assign people to some intervention, and the other would be to, okay, they're not going to get therapy, they're going to get just somebody talking to them, but they're not going to be doing our super cool therapy. That's awesome. And what they kept finding was, hey, the people that were assigned to talk to somebody, to have supportive listening, they got better. Oh, crap. Yeah, that's right, because that's a big part of what therapy and counseling is. So it wasn't, they thought it would be this kind of inert condition. Oh, nobody should get better with that. Yeah, you do. Which, again, it's not the worst thing. If your super duper treatment can outperform that, okay, well, that's important to know. Okay, having somebody who listens to you supportively helps some people, but this other treatment helps even more, right? If I do pre-post and I have two groups, I can get that information. But don't assume that control group is no treatment, right? Because if they're talking to somebody, it's probably not an inert treatment. They're getting something out of it. Another thing that they do to kind of get around that is, okay, we're going to assign you to get the treatment or to be waitlisted, right? So you're going to get the treatment, but not for another 2 weeks or 3 weeks, whatever. We're just going to delay a little bit. That way we can kind of measure you both at the same time and account for any kind of history effects. So that helps a lot with internal validity. But it brings up a bit of a problem in terms of external validity, right? If you tell me, okay, yeah, you came to this clinic, we see that you're really depressed. We've got this study that we're doing for this intervention to treat depression, which I think is really effective. And if you'd like to participate, sign here. You'll be randomly assigned to either start treatment, tomorrow, or to a wait list where you can start in 2 weeks. If I'm on the more severe end of whatever I'm dealing with, depression, anxiety, eating disorder, whatever, I'm probably less likely to say, yeah, I'll sign up. Right? Because there's a chance, a 50-50 chance, that I'm going to be stuck in this waitlist group and not have to start. Now, I don't mean to study. I'll just see somebody else that I can see today. Right? And so that study may not generalize to people who have more severe pathology, who have more urgent needs. It may be more applicable to people who are willing to take the chance of waiting 2 weeks, 3 weeks, however long that waitlist period is. So again, other things to look at when you're reading that research. If they're using a waitlist, how long is the wait, and what's the severity of the people in their study at usually at pre-intervention. Last thing to think about in terms of clinical outcome research is what outcome did they measure? What outcomes did they not measure? And it's something that can be tricky to figure out. What are the right things to measure? Right? So if you're looking at intervention for, okay, we're trying to help people with PTSD, obviously you're probably going to measure PTSD symptomatology. Yeah, that's good. That's a great thing to measure. But there's going to be some pretty clear demand characteristics in terms of, okay, you asked me these questions about intrusive thoughts with intervention. You're asking me the same exact questions. Oh, I know you want me to score lower. I'm going to say lower, right? So that's going to play a role. So you probably also need to ask some other things that maybe they're not going to assume you're looking for change on, but that probably should change, right? And this may often involve getting somebody other than the person getting the intervention, getting their opinion. Okay, what do you think happened with them? Or if we're talking about people's romantic partners, how's your communication? How's your relationship before and after? Because if the PTSD is getting better, then that relationship should be getting better. We can say, okay, how many days of work did you call in sick this last month after treatment? Okay, how many days did you call in sick this past month? Right. So we can get some other types of data other than the thing that they expect us to be measuring that may give us a better idea of, okay, what is the true impact of this intervention. If you focus only on symptom reduction, you're going to be missing a big part of the picture. Okay, that's all for now. Take care.